Hello everyone. Have you ever wondered how computers instantly detect and understand the text information from the images or the scanned documents? Optical character recognition (OCR) is the technology behind it. Today we are going to discuss about one such OCR tool, Surya OCR, which is blazingly fast for line level text detection. Let's get started. It expects at least Python 3.9 to be present in the system. In my case, I have Python 3.11. If you are running with a lower version of Python, ensure to upgrade it to at least 3.9 or above. The second one is PyTorch. If you are using CPU based machine, pip install -u torch will upgrade PyTorch to the latest version. If you are using GPU based machine, ensure to install PyTorch with CUDA. In my case, I'm installing with CUDA 11.8. Wait for the installation to complete and we are good to go. We can go ahead and install Surya OCR. Surya OCR supports multiple languages. For the test, we are going to take a Hindi article from Wikipedia. This is a multi-column layout. We are going to use snipping tool and cut down this particular section as an image. I'm going to save this image as test.png. Surya OCR supports both Python and CLI interfaces. Let's do the Python interface first. Let's load the test image. Image.open test.png, path to our image file. Let's print the image. This is a multi-column layout which we saved. Okay. Now we have to load the model. Load model and load processor. Model comma processor equals load model. Load processor. Sorry for the typo. If you are running this code for the first time, it's going to take a little bit of time for you to download the model from Hugging Face. The model size is around 130 MB, but on the subsequent steps, it runs faster. In our case, it ran in 2.31 seconds as the model is already cached. Now let's move to the detection. From Surya.detection, import batch inference. The batch inference interface supports multiple images in one shot. In our case, we have only one image and we had to pass the model and the processor. It takes hardly 8 to 9 seconds for detecting this image, and it since we haven't saved it to a variable, it will print the output. Here we can see it took around 10 seconds. Okay, and these are the bounding box coordinates, and we have the heat map and also the affinity map. Let's go ahead and save this to a variable. Prediction is equals. Okay, now prediction of 0. Since we are running with only one image, let's print the heat map. So this is the heat map, and let's print the affinity map. Yeah, this is the affinity map, and we can print the bounding box coordinates. These are the bounding box coordinates. Wouldn't it be great if we can plot these bounding boxes onto the original image and then see how well the text detection has happened? Let's do that with CLI interface. Once we install Surya, we can see Surya detect CLI interface. Let's print out the help menu. Surya detect comes with one mandatory argument which is passed to your input file, basically the image or a PDF. And there are a couple of optional parameters. Result directory, if you want to specify where to save your results, and if you want to specify the maximum number of pages to process. For instance, if you have a longer PDF, imagine you have a PDF of 1000 pages and you just want to process first 100, then you have to specify hyphen max 100, and hyphen images saves your output into a folder, and hyphen debug is to run it in the debug mode. Let's quickly run this command line tool with our test image. So Surya detect, path to my test image, and hyphen images stores the output inside the folder. Let's wait for 10 seconds. The output should be present in a folder. Okay, the detection has happened. The output is stored in results, Surya test. Let's open it up. Okay, results, Surya test, and here is the output. Let's open the bounding box file, zoom in a bit. Okay, so here we can see the red lines. The bounding box has been plotted. I guess it has done quite decent, except the headers in this right column, the headers were missed, and here the second level header has been missed. And in case of text, most of the text has been detected, and even the footers are detected. One important point to note here, we haven't done any extra step for integrating GPU with Surya. As long as you have installed the right version of Torch with CUDA, Surya automatically detects GPU and utilizes it. To confirm, I am running on a GPU based environment. Let's go ahead and run the NVIDIA SMI command in the terminal. Here you go. Right now the utilization is around 35%. Okay, let's go ahead and perform the same test once again, and let's hit NVIDIA SMI, and you can see that the third process is utilizing the GPU, which is our detection process. Surya has done the detection, and the detection is over here. So this is one of the main advantage of Surya over Tesseract, because the Tesseract OCR is CPU based, whereas Surya can either be CPU or be GPU. It supports both CPU and GPU. If we compare the benchmark present in the GitHub, it is evident that Surya is much faster and more accurate than Tesseract OCR. But it doesn't make sense to perform a comparison of Surya OCR with Parallel OCR or Easy OCR, because it's not an apple to apple comparison. Parallel or Easy OCR has been there for a long time, and Surya has just started. So there are a couple of features Surya OCR team is working on, like text detection and the table and chart detection. Maybe once these features are released, we can take up the Surya OCR and run more and more tests with a lot more images and perform benchmarking tests to see how well it spans out. Until then, thank you very much for joining with me on this video. We are going to explore on many other AI tools in LLM, NLP, and computer vision spaces. Until then, see you, bye bye. Please don't forget to like the video and subscribe to the channel. Thank you.